Hi. Hi, everyone. I'm sorry you're here when you could be eating lunch, but I hope to make this an enjoyable presentation for everyone. My name is Nikhil. I'm an engineer working on the Android platform team at Uber. For the past few years, I've been fascinated by the complexity of our mobile landscape. On one hand, we're able to build rich and magical user experiences for our app users, sure, but I have a dream. My dream is that the magical experience extends to the engineers too. So there's three tenets to the vision, and I'm going to be talking about a little bit about our Android infrastructure at Uber. We have three tenets to the vision. We want best-in-class tooling. We are always improving. We want to chip away patiently at long-standing complex issues. And finally, we want to be accountable. We want to maintain a high standard of service. Some of our peers at this conference have already talked about SLOs, SLAs. I'll be going into that a little bit, but not in too much detail, because according to me, a seamless code merge is more than just, say, the metrics that we're talking about. So let's talk about being accountable, and to do that, I have to explain a little bit about how we keep ourselves accountable at Uber. This is a general graph. It's not from internal numbers, but it's something I'm going to use to explain what an SLA really is. The details of the graph don't really matter, but the circled areas denote areas of concern in any such graph, right? Where there's a spike, it's considered a degradation. If you work at any company that watches metrics like this, someone comes to you and says, why did it spike? Can you fix that? And obviously, we use graphs like this as well to benchmark our Android infrastructure and make sure it's maintaining a high level of service. So here's a quick definition. A service level agreement is a contract between a service provider and a customer. These are definitions I wrote up, so don't grill me if they're not specifically correct, but I'll try my best. And an SLO is a service level objective is an agreement within an SLA describing the acceptable performance threshold of services encompassed in the agreement. I'm going to make an example that I also made up, so don't roast me. But if an SLA is that sliding door should open when reaching the door, then maybe an SLO is like a motion sensor must detect a motion signal 99% of the time. OK, so I talked a little bit about that. And we care that merging code is seamless for our engineers, and it's not always about the metrics. So we have a set of objectives that are governed by these metrics, but we don't necessarily hold too much credence for them. In the next few minutes, I'm going to try to summarize the other things we do other than just looking at the metrics. I'm going to talk about how it started for us at Uber, a little bit of history of what our stack used to look like, our approach to the problem, how that's gone over the past few years, how we're iterating a bit more on that approach, and then what's coming next. So let's go back to 2016. Let's talk about how things were at Uber. If you've been attending DroidCon over the past few years, you've probably come to some of my peers' talks where we talk about changes to our build, problems we used to face in our stack, and I'm going to dive into that briefly here. So the first thing we had in Jenkins, we were using, in 2016 we had Jenkins. And Jenkins, does anyone still use Jenkins here, by any chance? Yes, we have a few. I like Jenkins. I do. I really do. It's very configurable. It's a bit dated, sure, but, where will you find something like that that's been so, available for so long and still runs on prod infrastructure for so many companies, right? But there's some problems with it, And this meme I found was the best representation of what I found was problematic with Jenkins, which is that the best thing about Jenkins is you can make it do whatever you want, whenever you want. The worst thing about Jenkins is you can do whatever you want, whenever you want. And this is actually something that happened to us because we faced so many instances of config drift. People couldn't find their logs. There was no standard way of taking care of things. You could invest and build all that infrastructure, sure. But after a point, sometimes maybe you're thinking, can't this all be already built in? Do we have to be using things that have dangerous lists of vulnerabilities that are never updated or fixed, that are hosted internally? Do we have to use plugins that have a bunch of issues as well that we can never maintain or fix? Do we have to staff a whole team to do this? It doesn't seem like a good use of our time to deal with all these issues as well. It became dangerous to rely on it with a laundry list of vulnerabilities and an increasing cost basis. This is what it feels like every time I look at this, right? I'm just freaking out every time I'm trying to figure out whether my build failed and where it failed and why, trying to find my history. And this console output also, it wouldn't be nice if there was some built-in log parsing, breaking down some of these logs, telling me what steps running where, all the stuff you have to build manually. Maybe there's plugins for it. I haven't investigated, but it's not fun. It's not fun to read. Engineers don't like it. And this is what I mean when we talk about seamless. If I put an engineer in here, they have to be able to understand the context as soon as possible. They shouldn't be combing through logs. We shouldn't be building more complex custom tooling to log parse. Sometimes, there's entire companies that we have in the industry today that take care of these problems up front, right? Okay, so I was talking a bit about Jenkins. It's not the only thing. That's just, for running workloads, for running builds. But we had another problem. We had a main branch, and you're familiar. Everyone has to merge code to the main branch in order to deploy code. We had a main branch, but it could break. It broke all the time in 2016. We couldn't actually prevent our engineers from breaking each other. The app was getting way too big, and everyone was landing code over each other nonstop. If we had to release the app, say at 5 p.m., at 2 p.m., there would be hundreds of engineers trying to land code over each other. And good luck to you if you worked on a library. You were about to break everyone, and it's happened before. And it's very, very not ideal. Our release days are like this complicated song and dance between engineers trying to force their code in before other people broke them. You can imagine the chaos of a breaking change that needs to be rebased and tested by everyone else before it's committed to the main branch. And then you have to launch the app, and then you have to test it after that. And this is quite mission critical. The way our release cycle works, we release almost every week, and we're rolling out incrementally over that week. It's mission critical. Features have to ship on time. The business is affected if they don't, and the business is affected if they're broken. And things can still go wrong if you don't deal with your merge conflicts like this, which is apparently on a production app where someone just decided, let's just put both the buttons in, right? Okay, so I talked about engineers. Engineers can break each other, fine. We should protect engineers from breaking each other. That's understandable. But what if they can't even build the code, right? What if they can't even test the code quickly enough? At the time, and this is 2016 I'm talking about, so this is probably not relevant today anymore, just giving you context, Gradle was very slow for our large multi-module projects. CI could take 3 hours to land. We have a huge code base, and it was just not scaling. We could wait 45 minutes for a clean build sometimes. And I'm going to go into some numbers back then, what we were facing. And a meme from Gautam is the best one I could use for this, right? We could wait for Gradle builds on a different planet. That's how slow it was at the time. So we have this approach. I've just given you 3 layers of context here, whether it's Jenkins, whether it's merge conflicts, and whether it's to do with Gradle, right, our build system at the time. We have SLAs and SLOs. OK, someone at some level of the organization said, hey, we should have this contract. But we have these tools that don't serve the contract, really, right? We have to work toward improving our workflows to sort of fulfill the service contract we're agreeing with our organization. So it's not seamless, right? It's painful. That's what I'm getting at. So how do we make it seamless? OK, so one product we said we developed at the time, it's called Submit Queue. And it's our solution to clean merges in a main branch. And I will explain a little bit about Submit Queue right now. It's not too bad. We're already on our way to clean merges. Essentially, with Submit Queue, you always have a green main branch. So what is a merge queue, if you're not familiar? And before I do this, how many of you are familiar with merge queues here? Yes, a few people. So it's a good thing I have this slide. So a merge queue, I'm going to read the slide directly. It speculates on the probability of an incoming change introducing a merge conflict for other changes in the queue. It will rerun builds if it detects a change in the tree that affects other changes in the queue, right? It does automatic conflict checking. It reorders builds based on the best possible order for commits to land. We have a blog post on this, and it's a great paper. I would recommend reading it if you'd like to get familiar. But I'll give you a little bit more of the meat of it here. When you assume all changes depend on each other, you have to compute 2 to the power of n minus 1 builds. That is every possible combination. You test every change against every other change. But you can make this naive assumption, and even if you don't test, even if 2 changes are independent, if you assume they're dependent, you're still going to have to compute all these change sets. That's the naive understanding, right? You just assume they're all dependent, test everything against each other, see what happens. But if you can identify 2 changes that are independent, that's when you really leverage the power of parallelism in this kind of queue, right? You can do more work in parallel by being able to speculate which changes could land with each other, and you can discard unnecessary builds faster. So I know this is a bit, what am I getting at, really? I'm trying to simplify this, but by saying if you can detect change conflicts, you can find a better way to parallelize. Better parallelization means we can handle more throughput. And this is, I'll give you an example here. If the maximum number of changes in an hour is 500 changes, and you have 500 worker machines, the 50th percentile, 95th percentile, and 99th percentile turnaround time gets reduced to 1.2 times of the ideal model of performance stated in this paper. So in other words, if you're able to accurately allocate your capacity according to the workloads that you're expecting with such a queue, you can achieve nearly, 1.2x is not bad. It's obviously not going to be one of the perfect model of performance. But this is pretty close. So submit queue keeps our main branch clean, which greatly increases our ability to produce code. Let's talk about Buck next. So we have an organizational agreement on how fast builds should be as well. Fast builds, after all, help us with seamless merges, right? We migrated to Buck from Gradle, and we saw a dramatic performance improvement that allowed us to near our performance goals. For example, in 2016, again, old data, but when we used to build our apps, a clean build could take 8 minutes, 40 seconds, and 3 minutes, 20 seconds for us. So on average, our builds were 2.6. For the worst case anyway, we would get 2.6x faster for a clean build. And on average, it was more than 5 times fast for all the other cases. I think this is, it was pretty useful for us to get engineers producing more code quickly. But that's just the build system, right? What about Jenkins? It's the CI that powers everything. It's also it's also important for code merging. It has to be reliable, it has to be fast, it has to be correct. But our capacity requirements and self-hosting Jenkins was getting expensive, and we were pushing Jenkins to the limit, really. So it was affecting our availability and our quality of service, and we needed a solution, so we migrated. There's plenty of tools today. There's some peers here. We're talking about Bitrise, we're talking about Circle CI, we're talking about BuildKite. All these are modern offerings that offer a great deal of configuration and a slightly more sane framework for defining workloads, according to me anyway. So how did this go? Everything is done, right? There's actually nothing left to do, and we're done here. Or so we would think. I would think we were done, right? I thought things were great. But we found more problems, right? It's never that easy. For example, in reality, we can't solve everything perfectly. We want to make it a net improvement. We can acknowledge that, but we can't stop there. Recall, we want best-in-class tooling. We're always improving. We want to be accountable. We want to be accountable to our customers. So here's what happened with Buck, right? We had way faster builds, but community support was lacking. We were, at the time, the only company that had something like this that was using, Buck to build Android code. And internally, we were, the only stack using Buck other than, another monorepo that, it's a different type of monorepo. The two mobile monorepos were using Buck, right? But they couldn't share a lot of stuff. Android is pretty specific for a lot of things. Other teams were using Bazel at Uber. We couldn't share anything with them. The industry, there are people who are using Bazel as well, who are using Gradle. We couldn't share anything with them. Things wouldn't just not work because we picked a non-standard build system. What's the second thing? OK, submit queue. Sounds great. Main branch is green. It was rarely broken. OK. But it's still powered by CI, right? It's still powered by machines that need to run tests. So if that's slow, it doesn't matter how good your merge queue is. It's still slow. And it affects the speculation. It affects the time for things to land. Finally, with CI, even though it improved our CI, we'd gone to a more modern CI offering, we still needed to build tooling around the modernized CI for our engineers to find it as magical a user experience as it could be. So, it's not as simple as just moving to a platform that looks nice. You also need to build into the platform that you choose in order to provide these optimizations. I'm trying to talk about a pattern here, a way of thinking. It's not really about improving one area at a time. You kind of have to improve all of it, bit by bit. It doesn't happen overnight. That impact that you saw 6 months ago is gone the moment the code base is 30% bigger. That's just the way it works. The work just never ends. You're always migrating, you're always improving. So could we fine-tune submit queue? Could we fine-tune Buck? Could we fine-tune CI? Yes, of course you can. Everyone's always going to say that. For example, in SubmitQ, and we did one small optimization for SubmitQ that had huge benefit. We decided, instead of making engineers wait for reviews for code, what if we allowed engineers to put up their code, and if it was reviewed, it could land automatically into the queue. They're no longer waiting. The code does not go stale. It lands as soon as it's approved. But OK, that's cool, but it doesn't address one thing. We want also SubmitQ to be fast. So it's one thing to get the engineers to land code automatically. They love that. But if the code still lands slowly, or if the code is stale, then that engineer is going to be hands-off. That code is going to go in this queue, and then it's going to break if it has to rebase. If it has to. But then that person has to come back and take care of all of that. And where we were giving them a contract, a guarantee that they would land their code, they've now got more thrash. So that's not ideal, right? So we added a tweak. Before I talked to SubmitQ, before we landed code to SubmitQ, we would run one final build. We would take that change set, and we would rebase it against the main branch before it even goes into the queue, as a final check, as a final step to validate that this change can merge cleanly, runs all the tests, runs all the, and the other thing is, if you run that last change set, it's validating and it's submitting to the cache. You're uploading artifacts to the cache all the time. And since SubmitQ is always landing commits, right, that cache is always getting updated with different artifacts at every single commit. But if you can reduce the time between a change set going stale and it landing on the main branch, you're essentially able to leverage the cache, the power of the cache, which has most of these artifacts up to date, in order to make your builds faster. In other words, when we were letting SubmitQ and letting people land code when they wanted, we couldn't leverage the cache well enough to get a good numbers and good performance out of SubmitQ. The moment we added a workflow to poll for diffs that were ready to land, and we automatically ran tests on those diffs that were ready to land before they went into the queue, we saw great build time improvements. We saw much more developer happiness, and we saw much more of a clean, green main branch. We're also exploring Bazel internally. I know that just changed to Bazel. There's a reason. Yes, we're exploring Bazel internally. We use Bazel on other teams at Uber. It's being adopted throughout the developer community. Being on Bazel allows us to share tooling internally and externally, converging on the best possible experience, build experience for our engineers. Using standardized tooling helps make our workflows more resilient and less error-prone. And there's, if an engineer can look at a Bazel log or stack trace and they know that that's an open source definition for something that they can go and look at, and they can fix if there's a bug, is way better. And as a community, we all have to help each other out in a way, right? We don't want to be building custom solutions for all our companies every single time. We're all, we're all Android engineers. We love open source. I mean, by definition, I think. So we want that's going to help with more seamless code merges, right? More transparency between what build system you're using and sort of who's using it in the industry, who's contributing tools. So exploring Bazel lets us do this. Finally, OK, our modern CI looks nice. Great. It's not Jenkins, even though I have a soft spot for Jenkins. It's not Jenkins, right? It's got much more improvements. But you need to do stuff in there. You still need to do stuff in that modern CI. It's not as simple as just, OK, we've solved some basic problems with how slow the page is to load or how fast it is to allocate jobs. That's, sometimes it's provided by the third-party infrastructure, but you're still giving it a machine that needs to run a workload, which means you're going to have to provision and think about all of the sub-problems of setting up that machine alone. And that's not really related to any sort of CI orchestration layer we're talking about, whether it's Jenkins, whether it's Circle CI. You still have a host. You still have to take care of how, say, Git checkout happens, right? Git checkout can be really slow if your repo is very big. So a modern CI infrastructure and a good, declarative way of defining how to provision these machines versus, say, a bunch of old JJB macros and bash scripts makes this a little bit easier, right? Makes it a little bit easier. You're making your CI more resilient, and you can build more automation, more interesting tooling around it. So the work never ends. You're always migrating, always improving. But what I do feel, a broader alignment on excellence, in other words, these metrics we talked about, right? When I came to Uber, I saw these numbers, and I was thinking, how are they going to expect me to just solve this today? It's not possible. But it's more like a guideline, right? If you consider that excellence, if you say, OK, we're going to provide an excellent service, your work just sorts itself out. You're just always seeking that excellence in a way. And I used to be afraid of this change. I used to think, oh, things are okay. I wonder how we could ever fix that. But now I'm empowered by these sort of metrics, these numbers, these agreements. I feel responsible for the business. And I empathize with developers, right? I want their experience to be best in class, period. That's how it has to be. And it could always be better. And so these agreements, they're like a guideline in the right direction. So used effectively, they can empower you. So thank you. Thank you for coming to our talk.